we are going to explain about project titled Crop Yield Prediction using RNN feed-forward and LSTM Neural Network. Accurate crop yield estimation and prediction play a vital role in optimizing the resource allocation, informing the decision making, ensuring the food security, promoting the sustainable practices, and addressing the market demands. Factors such as climate, condition, soil quality, management, and farming technique influence the crop yield, making the accurate prediction essential for efficient agriculture and effective policy planning. The objective of this project is to utilize an agriculture production dataset. We train the three neural network algorithms that are RNN, feed-forward, and LSTM neural network on this dataset to build a neural network model. This model can be employed to predict whether the crop yield will be high or low when applied to new test data. The test data consists of location, year, and agricultural land area values which are inputted into the neural model for production prediction. These are the basic requirements needed to build this project. Operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements are Python IDEL with version of 3.7. These are the modules we developed to implement this project. The first module is upload the agriculture dataset. This dataset consisting of information like location, year, land area, and many more. And the pre-process the dataset. In this module, we are pre-processing the dataset by handling the missing data, by the feature selection, and by splitting the data into the testing part and the training part. And the third module is run RNN algorithm. In this module, we implement the RNN model using the deep learning library like TensorFlow to build an RNN model and create a function of train RNN model by using the pre-processed dataset, by designing a function to tune the parameters like of number of hidden layers, number of units, learning rate, etc. And the fourth module is run LSTM algorithm. This module will implement the LSTM model by using the deep learning library to build an LSTM model and by using the pre-processed dataset to tune the hyperparameters. The fifth module is of run feed-forward neural network. And to implement this module, we used the deep learning library to develop an neural network model and by using the pre-processed dataset. And then accuracy comparison graph. In this graph, we plot the number of algorithms we used with the values assigned to it. And the seventh module is predict disease using the test data. In this module, we implement the pre-processing functions to handle the missing data, feature selection, and normalization for the disease dataset, and give an data for detecting the disease for the crop. And the last module is top 6 crop yield graph. In this module, we extract the crop yield data from the dataset and determine the top 6 crop yield based on the extracted data and plot it as a form of graph. For execution of this project, we need to double click on run.bat file and we get a screen like this and click on upload agriculture dataset button. Here, need to select the dataset and click on select folder. And we get a screen like this where the dataset is loaded with an feature of name, state name, district name, crop year, season, and the area where it is. And click on pre-process the dataset. By clicking here, we get the screen of processing the dataset by removing the missed values and feature selection and normalizing the data. And the third module is clicking on run RNN algorithm button. Here we get an RNN prediction accuracy of 58.84 and then click on Run LSTM algorithm. By this, we get an accuracy for the LSTM prediction is of 78.73 and then click on Run Feed Forward Neural Network. By this, it gets an accuracy of 62.78 and then click on Accuracy Comparison Graph button. Here we get a graph where x-axis represents the algorithm we used in this project and the y-axis represents the values assigned for each technique of accuracy like of RNN accuracy, LSTM accuracy and feed-forward neural network accuracy, and then close this graph and click on Predict Disease using Test Data button and select the test data from this folder and click on Open. And here the data that is present in the square bracket represents the crop and the predicted as the crop yield will be less, and some data it will predicted as crop yield will be high. And click on top 6 crop yield graph. And here we get a graph like this. In this graph, x-axis represents the state names and y-axis represents the rainfall, rice, coconut, sugarcane and various top 6 crops in the other states. First graph is for the state versus rainfall and the second graph is for state versus rice, third is for state versus coconut, fourth is for state versus sugarcane and of many more. In this way, we will predict the crop yield by using the RNN feed-forward and LSTM neural network. Finally, I conclude that the project is successfully developed of using the neural network-based predictive model for estimating the crop yield based on location, year, land area. The model accurately classified the crop yield, providing a valuable insights for agricultural decision making. Future research can enhance the model performance and expands its agricultural applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.